Okay, it's now time to take our lesson quiz. Question number 1. What is the difference between velocity and acceleration? So velocity is going to be how fast you're going, and then acceleration is going to be how fast your speed is changing. So it's the change in your speed per unit time. So it's how fast is your speed changing. So it says to give an example of when acceleration would be 0. So that would be if you're in your car and you're driving down the road at a constant speed. So if you're going at a constant speed, your acceleration would be 0. Okay, give an example of when acceleration is not 0. So again, you're in your car, you're going at a certain speed, and then you hit the accelerator. So then your speed begins to change. Accelerations change your speed. Question number 2. What is the difference between the average velocity and actual velocity of an object? So that the average velocity is you've got a starting point, and then you got an ending point, and then you got a certain distance. So this is the total distance that you travel, and then it takes a certain amount of time to go from here to here. So when you divide them, that's going to be your average speed. Okay, the actual speed can be different. So you could speed up, you could slow down, you could speed up, but then when you average all of those different speeds together, it could equal this average speed here. So give an example of when they are the same. All right, that would be if you're going from here to here and you are going at the same speed all the time. So 5 meters per second. So you're going 5 meters per second here, 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 and here. So your actual speed is 5 meters per second, and then your average speed is 5 meters per second. But give an example when they're different. So we talked about going up and down hills, so that you have a certain distance over to here. It took a certain amount of time to get to over here, so you have an average speed, but you're going to be going faster than that average speed when you're going down hills, and you're probably going to be going slower than that average speed when you're going up hills. But then it has an average speed over the entire trip. Question number 3. A car is initially at rest. It travels at 3 meters per second squared for 10 seconds. Calculate how far it travels. So what variables are given in the problem? So we were told that it is initially at rest. So that means that v sub I is equal to 0 meters per second. Okay, we're also told that it's going at 3 meters per second squared. What is 3 meters per second squared? That's an acceleration. So we're told the acceleration, and then we're told 10 seconds. So that's going to be the time. And so we need to know how far is it going to go. So we need to know R equals what. So that's the goal, is to figure out the R. So then what equation has an R and a v sub I and an A and a T? Well, it's the how far equation. So we're going to say R is going to be equal to v sub I times T plus 1/2 A T squared. So we know the initial speed was 0 because it starts at rest. So that means we don't need to worry about that piece. So now we've got 1/2, and then the A was 3, and then the T was 10. So we need to square that. So 10 times 10 is 100, times 3 is 300, and then 300 divided by 2 is 150. So this thing will have traveled 150 meters. Okay, the acceleration that is used when something is falling is called what? The acceleration due to gravity. And what is its numerical value? So that is g, and it all depends on how many significant figures that you want. So we could use 10, which is going to be really one significant figure. We could use 9.8, so that's good to two significant figures, or we could use 9.81, and then that would be good to three significant figures. So it all depends on the accuracy that you want. And then don't leave it like that. Remember, we need to put meters per second squared. So don't just write down numbers. You should always put the units when you get done with it. And then number 5, the distance an object has moved and the time it took it to do it in are given below. Graph and interpret what is the data trying to say. Okay, so since we were given velocity and time, then that means that we're going to want to have a velocity versus time graph. Boy, this is messy. All right. Okay, there we go. Okay, so let's make a graph here, and we want the time to be going sideways. So on these graphs, time is always going to be the independent variable. So it's the one that can change, and then the velocity, that one's the dependent variable, because depending on time, that changes how fast you're going. So we're going to say that the time is going to go from 0 to 20. So we're going to say that it's going to go 5, 10, 15, and then 20. And then we can put the units down here and say that our units are going to be in seconds. Okay, and then we're going to go up and down, and the velocity goes up to 60. So how would you do that? So 10, 20, 30, 40, 50, 60. And so our units this time are going to be in meters per second over here. So our first one is going to be at 5 seconds. So 5, 10, 15, 20. So 5 seconds, we should be at 15. So if this one was 10 and this one's 20, then 15 would be right about here. Okay, then the next one says time is going to be 10 seconds, and then we want to go up to 30, so we're going to have 10, 20, 30, and so now we're going to end up with something like that. And then the next one is going to be at 15, and then we want to go up to 45, so 10, 20, 30, 45, puts it right about there. Okay, and then finally we're going to have 20, and then that needs to go all the way up to 60 up here. Okay, so the question is, what is this thing trying to tell you? Well, you should, if you did a really good job, and I encourage you to do this on a nice piece of paper with a ruler and measure everything out very accurately, but it should be a straight line. So when you connect all of those points, it's a straight line. What is the slope of a velocity versus time graph? So it's going to be rise over run. So the rise is going to be velocity, the run is going to be time. So the slope is going to be the change in velocity and then over time, but that is acceleration. Okay, so the slope of a velocity versus time graph is going to be the acceleration of an object. What do we notice? It's a straight line. It is a constant. So this thing is accelerating. So that's what we end up with. Okay, and we could actually calculate this. So if we wanted to actually calculate it, since we know that this is a straight line, I'm going to use this point, and I'm going to use this point up here, so that here's my rise, and then here's my run. So that my change in velocity is going to be up here 60 minus 0, which is going to be 60. So 60 minus 0. And then my change going this way is going to be 20 minus 0. So that I'm ending up with 60 over 20, which is going to be 3. And then it's going to be an acceleration, so we're going to say 3 meters per second squared. So that's the interpretation of the graph. So I would, if you're one of my students, I would expect you to be able to do this on an exam. Okay, we're finished. So in our previous lesson, we talked about Newton's first law of motion. Okay, now we know what speed and acceleration are. So in our next lesson, we're going to talk about Newton's second and third laws of motion and what has it got to do with forces. So I will see you then.